Okay. Hello everyone. Good afternoon to all professors and the scholars. And I'm Haocong RAO from the College of Computing and Data Science, Nanyang Technological University. And the title of my report is Advancing Skeleton-Based AI Innovation in Person Re-identification and Beyond. So before I introduce my research, I will first briefly introduce my educational background. I obtained my bachelor from South China University of Technology, and also have some research experience in Chinese University of Hong Kong and Shenzhen Institute of Advanced Technology. And now I'm pursuing the PhD degree in Nanyang Technological University. So my main PhD research direction is skeleton-based person re-identification, SRID, and 3D signal processing, factual by learning, interdisciplinary AI. My PhD supervisor is Prof. Chen Miao and Prof. Cyril Liang. So I will thus clearly go through some not so important part, research project. I participate in some national project, and I'm also the project lead of the AI research project of AI Singapore. And here's some professional service. I'm the program committee member of IJCA, and also I have co-organized some international workshops such as the Agilist Aging workshop and the cognitive and physical clarity seminar. So here's some award that I received. Okay. And it's the overview of my publication, and my main research direction include the skeleton-based person re-identification, 3D action recognition, AI for healthcare, and large language model application. So to better illustrate the value of this research, I give some example. For example, the human skeleton-based person re-identification can be applied to human checking and security authentication. And the 3D action recognition can be applied to the human-robot interaction and auto-driving car. And also in some game playing, the 3D action recognition algorithm can recognize the action of the user to play games. So here are some representative works that I published on some top journal and some conference. Okay. So I will introduce my main research content. First, I will illustrate the background of my research. Maybe the skeleton-based personality is a very new and emerging topic that some people may not be so familiar. So I will introduce the background. And then I will introduce some AI model for this area. And finally, I will conclude and provide an outlook for this area. Okay. So person re-identification is to retrieve and match the identity of a passenger from the database. So conventional methods, they typically are RGB-based or text-based methods. That means, for example, as shown in the figure, they input a 2D video or 2D image to learn the feature and classify the identity. So these methods, they are faced with many challenges. For example, they heavily rely on the visual appearance features, such as faces, and their performance may be easily influenced by some environmental factors, such as viewports, illumination. And they also usually require large high-quality image data, which is computationally expensive in real world. So we just think about a question, can we just use 3D human skeleton to perform the personality? For example, we use the 3D skeleton sequence captured from the depth sensors to perform the personality task. And here we show the 3D skeleton that corresponding to the RGB video. So the 3D skeleton can concisely represent the human pose. For example, the unique gait pattern, and we can extract the valuable motion information for this task so that we can address or avoid some problem faced by the previous methods. So the question is, why we study skeleton-based personality? I think there are some important reasons. For example, the 3D skeleton data, they can be captured from low-cost, non-intrusive, and accurate skeleton checking sensors. And they also have smaller data size, higher efficiency than conventional modalities, such as RGB images. And Another important reason is that we do not require any appearing information, which can provide better privacy protection. So I provide a very specific problem definition for this task. So we use the 3D skeleton to retrieve and predict identity of a possessed shell. So the 3D skeleton data can be captured from the depth sensor, like a KeyNet, or we can just estimate the skeleton from the videos. So the focus of this task is to learn the body and motion feature from the 3D skeleton sequences, and then query its identity from the database records. The key is to extract the discriminative structural feature of body and motion information of a person. So we propose several AI models for SRID, and which can be divided into 3 sub-areas. The first sub-area is sexual bias skeleton gait encoding. So we hope to encode the unique gait pattern based on skeleton data in a sexual bias manner. That means we hope to use the unlabeled skeleton data to directly learn the gait pattern. And the second is the unsupervised skeleton representation learning. So in some scenario, the label are unavailable. So we hope to devise some unsupervised paradigms to perform the purely unsupervised skeleton feature learning. And the last one is skeleton graph-based human body motion and relation modeling. We hope to model the 3D skeleton as graph so as to learn the human body and motion and their relational features. So the first one, direction, we for the first time introduced sexual vision into skeleton feature learning since 2020. And the most representative work is SGLA. So in this work, we develop the gait encoder-decoder paradigms, and that combine different tasks such as the reverse sequential reconstruction, skeleton sorting, and the sequence prediction to learn some useful motion properties such as motion consistency or motion continuity to have learn the gait patterns. And 2 key components is the locality-aware attention mechanism and the locality-aware contrasting. So the locality in our work is defined as the local context of a skeleton that may contain some high correlated or nearby skeleton that can have its reconstruction to learn the motion features. And we hope to use the attention to focus on the key gait states to perform such task learning. And we also use the constructive learning to focus on the motion continuity between different skeleton sequences so as to better learn the skeleton representation. The results show that our model can outperform previous methods, including depth-based methods and traditional skeleton-based methods and multimodal methods on different benchmark datasets. And this article also has been selected as the feature article of the IEEE department. And apart from this work, we also propose MGSCR, which is published on EJCA 2021. And this work, we combine different level skeleton graph to more comprehensively model the body structure and motion. And then we utilize the graph attention network to model the structural relation and the cross-collaborative relation that infer the correlation between adjacent graph level of skeletons. And in SMG, this work, we further improve this work by proposing more scale skeleton representation. And we also propose the omni-collaborative relation, which can integrate the correlation between the original graph level and its higher level graph representation. And we also devise multi-scale reconstruction mechanism. This mechanism aims to learn the inherent motion properties, such as the motion continuity and the different level skeleton correspondence. We propose the cost-scale skeleton inference and subsequent reconstruction mechanism. So the common key idea between these two works is to simultaneously capture the structural relations and the collaborative relation from the scattered data to learn gay pattern. The second direction, unsupervised scattered learning. So we propose CMMC. This is the most lightweight framework until now, and it is also the first unsupervised scattered representation learning framework for person ready. It can also serve as a general backbone framework for gait and action recognition, motion prediction, and other tasks. As shown here, our framework can not only outperform existing methods, different kind of methods, and it can also enjoy the small list parameter size and the computational complexity. And it can also be applied to different state-of-the-art models to improve their performance. So in 3D action recognition task, we also propose the first momental constructive based action learning paradigm. We propose scalable scatter augmentation strategies to sample more scatter sequence samples to enhance the model training. And this paradigm has been widely used in motion prediction post-animation. And we also received many good comments from professors such as Prof. Pietro Perena in Caltech, which evaluated our work to verify the effectiveness of constructive learning in action classification task. And the last one, skeleton graph-based human modeling. So MGSCR we have introduced before. So in this work, we also focus on the body component relation learning. And we devise multi-level skeleton graph can be used for post-animation, gait recognition, action classification. In our work published on CVPR, we propose the first transformer paradigm that unifies human joint relation learning for skeleton-based person ready. And we also devise graph structure trajectory prompted reconstruction to enhance the general high-level skeleton semantic learning, such as the temporal pattern in special patterns within the body and the temporal feature in the body joint trajectories. And our model also achieves state-of-the-art performance compared with other methods. So apart from my main research, I also do some interdisciplinary AI research that I am interested in. For example, we explored the first general evaluation framework for human personality assessment, such as MBTI test by ChatGPT, and we devised an unbiased prompt that can help users to receive fairer answer from the LLM. And we also devised consistency, robustness, fairness, evaluation metrics. This work has been applied to various LLM assessment tasks. And in other exploration, AI for healthcare, we also conduct a comprehensive survey on AI-based human gait analysis for neurodegenerative disease diagnosis. And we propose a vision to apply 3D scatter data for efficient gait representation and AI-assisted engine diagnosis. So this will also receive much attention from the researcher outside AI area. And after introducing my research, I also provide overview for some research project that I participated before. For example, some project related to the scanner data. We have developed a gait recognition system based on 4D depth video data to analyze the probability of depression. And we also develop a sleep quality monitoring device, whose accuracy is up to 90%. And these two projects has been applied to various university hospital troops with more than 10,000 clinical experience. Okay, so finally I will conclude my digressions and provide outlook for this area. So in the past few years, in SRID research, we have progressively improved the accuracy of the scatter-based person-ready models. And we also improved its generated to apply our model to different scenarios such as RGB asymmetric skeletons, multi-view skeleton, and unlabeled skeletons. And our framework are typically designed to be applied to diverse skeleton representation and can function as a generic product to enhance the performance of different models. We also have provided a systematic theoretical hypothesis and analysis for each key component of our approach to prove their effectiveness. In my PhD study, we also explored different areas in the different direction of this area. So in future, there are many promising directions. For example, we can combine 3D skeleton to improve the structural action recognition performance of different modalities, such as RGB images. And we can also construct a skeleton foundation model for test skeleton generation and various skeletal downstream tasks. And we are planning to develop and open larger scale skeleton data sets under different scenarios to improve the model generality and performance. And here I provide an outlook for both application and the impact of my area. So the skeleton-based personality model can have built lightweight human checking identification system for depth sensor. And we can also develop some specific chips for AI security products. And it can also, because our model requires small size of data, so it can be flexibly applied to public camera network to reduce the energy usage and facilitate the green digital transformation of cities. And another direction is that we can exploit the skeleton host-based identity-aware behavior and emotion prediction models. For example, we can just mention before we have conducted a survey to construct AI-assisted neurodegenerative disease diagnosis system based on the skeletal gait. And for public authentication and safety, we can develop skeleton-based identification models and combine other biometric features to enhance the public authentication systems. And our model can also be used to have check criminal and variant scenarios. Okay, here are all my presentation. Thank you very much.